Okay, so we're going to continue with our session. Now we're going to take question 3. Question 3 is dealing with the circle. As you can see here, here is the graph. We have got 3 circles. I'm going to read the question and then we will respond to these 3 questions. A circle with radius 6 centimeter is drawn. Here, 6 centimeter. A second smaller circle is drawn through the center of the first circle. This is the second one, passing through the center of the first one, and also touches the first circle internally, as shown in the diagram. A third smaller circle, a third one, is drawn through the center of the second circle and touches the second circle internally. Touch the second circle internally, as you can see there on the graph. So the process of drawing circles continues and forms a geometric pattern. So here are the 3 questions with having. Here we're going to respond to this question. The first one, write down the radius of the third circle. 3, 1. We are under here. 3, 1. The first circle, as they said, it is a 6 centimeter. Now, the radius of the third circle will be, the first one is 6. So if we want to get the radius of the second, it's going to be 6 divided by 2. And the radius of the second circle is going to be 3. So the radius of the third circle is going to be, I'm going to write it like this, radius of the third circle, it will be 3 over 2, and it's going to be 1,5, and the unit is a centimeter, because they say the radius is 6 centimeter for the greater one. So here's the answer for question 3.1. The radius of the third circle is 1,5 centimeter. Second question 3.2. Calculate the sum of the areas of the first 10 circles. The sum of the areas of the first 10 circles. So what are we going to do here? We need to remember the formula of the area of a circle. The formula area of a circle, I'm going to write it here, is a pi radius squared. This is the formula for the area of a circle. So if we want to get the area, we will apply the formula. Let me write here the radius as a geometric sequence. I'm going to write it like this. First one is 6. The second is going to be 3. The next one is 3 over 2. The following one will be 3 over 4. 3 over 8. 3 over 16. And then the next one will be 3 over 32. 3 over 64. Next one is 3 over 128. And the next one is going to be 3 over 256. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the radius for the 10th circle will be 3 over 216. So here we'll be having a geometric sequence. The first one is going to be radius squared is going to be 36. So we'll be having 36 pi. The next one is going to be 9. Yes, it's going to be 9 pi. Meaning, if we check here, our common ratio is going to be 1 over 4, because to get 9 is 36 multiplied by 1,4. So the next one here will be 9 pi over 4, and so on. If we want to find for the last one, here is the radius. We're going to take this radius squared, multiply by pi. So doing our calculations, let me see for the last one, because the next one here is going to be 9 pi over 16. So for the last one, the radius being 3 over 256 squared multiplied by pi. What are we going to get there? 256 squared. Yeah. And it's going to be 9 pi, the last one, for the last one, 9 pi over 65,536. And this will be the area of the 10th circle. Now, the question here is to calculate the sum. So, we need to write for our geometric sequence, the constant ratio will be 1 over 4, and the first term is a 36 pi. And remember the formula for the sum of a geometric sequence. I'm going to remind this here. The formula for the sum, then you go and check at the end of the question paper. They have given you the formulas. So the formula for the sum for the geometric sequence will be A times r to the power of n minus 1 over r minus 1. So this is the formula for the sum. Here we're going to get the sum of the first 10 circle. And we will be writing it like this. S10. S10 is going to be equal to, our first term is a 36 pi. And here we'll be having the radius. And the common ratio, this is a common ratio, is 1 over 4. 1 over 4 to the power of 10 to the power of 10 minus 1 over 1 over 4 minus 1. And after writing this sum, you're just going to take your calculator and you'll get the sum of the 10th first circle. Let's calculate. 36 pi, open bracket, another bracket for the common ratio, 1 over 4, close bracket to the power of 10 minus 1, then close bracket, down is 1 over 4 minus 1. There our calculator is giving us 150,796. So we're going to round it off to 2 decimal places. So the sum will be 150,80. And here's the sum of the areas of the first 10 circle. Question number 2. We're going to question number 3. And I'm going to clean the board. I'm just going to leave this question 3.3. I'm going to clean the board so that we'll be having more space for question 3.3. Okay, so here's question 3.3, the next question. Which circle has a diameter of 3 over 128 centimeters? Here are the radii for our 10 circles. If we having a diameter of 3 over 128, it means the radius will be 3 over 128 divided by 2. And then we get the radius. Now, what are we going to do here? In order for us to get the radius here, we will take this divided by 2. Divide by 2 is like we are multiplying by 1 over 2. So it's going to be 1 over 2 multiplied by 328. Here we're getting 3 over 256. Here is the radius. So they want us to show which circle is going to have this radius or this diameter. For that, what are we going to do? We will need to get the general term of our radii, as you can see them here. For a geometric pattern, the formula of the nth term is A, the constant ratio to the power of n minus 1. So now, we're going to equate. What are we going to get here? Our general term will be A, the first term is 6, and the constant ratio here is 1 over 2. 6 times 1 over 2, you get 3, 3 times 1 over 2. So here is going to be 1 over 2 to the power of n minus 1. This is the general term of the radii. So we want to get n, and this will be the circle which going to have a diameter of 3 over 128, meaning a radius of 3 over 256. So we're going to equate this. 3 over 256 will be equal to 6 times 1 over 2 to the power of 1 n minus 1. So I'm going to multiply the right-hand side by 1 over 6 so that I will eliminate this 6. What I'm going to do on the left, I'm also going to have to do it on the right. So multiplying by 1 over 6 here, the 6 will be simplified, and this other side, it will be times 1 over 6. What are we going to have? Let's calculate. 3 over 256 multiply by 1 multiply 3 over 256 multiply by 1 over 6. Then we're getting here 1 over 500. We're going to get here on the left 1 over 512 is going to be equal to 1 over 2 to the power of n minus 1. So, writing 1 over 512 as a power of 1 over 2, we're going to write it like this. 2 to the power of 8, we're getting the now 2 to the power of 7, then we get 128. 2 to the power of 8, 2 to the power of 9. Yeah. So here we're going to have 1, I'm going to write it here, 1 over 2 to the power of 9 will be equal to 1 over 2 to the power of n minus 1. Okay, so now it's easy. Having the same base, we're going to equate the exponent. And finally, we will have that 9 is equal to n minus 1, and n will be equal to 10. So, the circle, the 10th circle will be having a diameter of 3 over 128, or a radius of 3 over 256. So we have responded to this question. Which circle has a diameter of 3 over 128 centimeter is circle number 10. And we are done with this question number 3. We're going to go to the next question. I'm going to clean the board so that we'll be going to the next question. Here's the next question, is question 4. We're dealing with the exponential function here. You can see, given that f of x is equal to a to the power of x minus 1, for a being greater than 0, b to negative 5 over 9 is a point on a f. First question 4.1, calculate the value of a, and the question number 2.4.2, write down the range of f. So let's take question 4.1 down here. We're going to write f of x is equal to a to the power of x minus 1, with a being greater than 0, meaning a is a positive value. So now, if we want to get the value of a, we're having one point b, which is on the graph of f. So we're going to replace, meaning we can write this like this. Y is equal to a to the power of x minus 1. Here's the value of y, here's the value of x. So here we'll be having negative 5 over 9 is going to be equal to a squared. The value of x is 2 minus 1. So a squared will be equal to 1 minus 5 over 9. This negative 1 will be transposed to the left-hand side. So 9 minus 5, a squared will be equal to 9 minus 5, we get 4 over 9. And then they say the value of a is greater than 0, because if we want to take the two values of a, it will be plus minus 2 over 3. And s is greater than 0, we're only going to consider the positive value. A is equal to 2 over 3. And then we'll be going to the next question. Next question is write down the range of f. Range of f, we can have an idea. Remember, the standard form of an exponential function is normally given by this, a to the power of x minus q. And here, the value of q is given is negative 1. So this will be practically our horizontal asymptote. I can write this like this. Y is equal to negative 1. This will be our horizontal asymptote. So our graph will be on top of this horizontal asymptote. So now, if we want to get the range for 2, the range will be y will be greater than negative 1. Here's the range of our function. We can also write it like this. Y is a member of negative 1 to plus infinity, going up. So you can write it like this or like this. It's the same. And this is for 2 marks. And then we are done with the question 4.2. We're going to go to the next question. As we can see on the question paper, is 4.1, 4.2. Now we're going to take 4.3 before we go to 4.4. And that will be the last question on this question 4. I'm going to clean the board for us to have space. Okay. Here's the next question is 4.3. Dealing with our function. Sketch the graph of f clearly show the intercept with the x's and asymptote, if any. So we're gonna sketch the graph. We're gonna sketch the graph. Let's consider this to be, we're gonna sketch the graph, be up here. So this is going to be our x-axis, and then here will be the y-axis, here 0, and then as you can see here, our horizontal asymptote is y is equal to -1. -1, let's take it here, -1, let's take it here, here's our asymptote, so it's gonna be like this. And here also gonna be like this. Alright, here our horizontal asymptote. So here we're having 0, here is gonna be -1. Then if I replace x by 0, a to the power of 0, we're going to get 1. 1 minus 1 is 0. Any number to the power of 0 is 1. 1 minus 1 is 0. So we're going to have one point, our graph will be here. And the other one is here, B. I'm going to consider 2. Let's consider that here is 2. And the second coordinate is -5/9. If I try to get this value, approximately 5 divided by 9 is 0.5 approximately. So it's going to be somewhere here in the middle. 2, 0.5 is here, and let's take 2 is somewhere here. So we'll have our point here. We are sketching the graph. So here is our point B. We're going to call this point here B. B is here. And if we consider another value like on the left here, -1. If x is -1, let me try so that we're having an idea, because our graph will be on top here. If x is -1, what are we going to have? We know the value of a. We did find the value of a, it was 2/3. So we'll be having 2/3. We just want to have an idea for any point we're going to consider on the left here. To the power of -1 -1, then we're getting 1/2. So if I consider 1 here, we'll be having 1/2. 1/2, because here is 0, 1/2 can be somewhere here. So we can have another point here. And this will give us an idea. Our graph will be like this. Will be like this. Here's our graph. Here is our graph. We're sketching the graph. Yeah, so this is the graph of f. As you can see, here is our horizontal asymptote, as we have given the range is from -1 up and going to positive infinity. This is the graph. Here is the question 4.3. We are done. I'm going to clean the board and then we will go to the last question, and that is 4.4. Okay, here's the next question. Is 4.4. It is further given that C is a point on F at y is equal to 19/8. The question is determine the coordinate of C prime, the image of C, when C is reflected about the line y is equal to x. So if we consider this line y is equal to x, is going to be considered like the first bisector of our system. So it means if we are having here our system, the x-axis and the y-axis, y is equal to x will be this line here passing at the origin, like that. So if we want to have the reflection of a point here, it will be at the same distance the other side, like this. So just for you to have an idea, if we want to get the coordinate of C prime being the reflection of C on this about the line y is equal to x, we're going to consider a function. And this is what we're going to have first to get the coordinate of C, and then we'll get the coordinate of C prime. So our y is given 19/8. We're going to write 19/8 is equal to a function given by a to the power of x over -1. Remember, we got the value of a at the first question. A was equal to 2/3, so we're going to write 2/3 to the power of x minus 1. So here's our function to the power of x minus 1. C is a point on F at y is equal to 19/8. So now, we want to get the coordinate of C, and from there we will get the coordinate of the reflected point that is going to be C prime. So, -1 transposed to the other side will be having 19/8 plus 1. What are we going to get? 19/8 plus 1. We're getting 27/8. So here is going to be 19/1 plus 1. We get 27/8, and this will be equal to 2/3 to the power of x. And then I'm going to continue the other side. 27/8 will be written like this: 3/2 to the power of 3. Because 3 to the power of 3 we get 27, and 2 to the power of 3 we will get 8. And this will be equal to 2/3 to the power of x. Now, to get the same base here, we're going to get the inverse of this. If I want to have the same base like on the left, 3/2, it means we're going to have 3/2 to the power of -1. And with this x, it will be 3/2 to the power of 3 will be equal to 3/2 to the power of -1, and then it's going to be minus x minus 1 times x. This is what we're having here. 2/3, if you want to get the inverse of 3/2, it will be 3/2, and the exponent will be -1. As we are already having an exponent of x, it's going to be minus x. Same base, we compare or we equate the exponent, our x will be finally equal to -3. And this will give us now the coordinate of C. The first coordinate of C is -3. We have done the calculation. And the second one will be 19/8. From here, we can get the coordinate of C prime. As I've shown it earlier on, if we having on the system y is equal to x being the first bisector of the system, so the coordinate of C prime we're going to reverse is going to be 19/8 and -3. We're just going to reverse this coordinate, and that will be the coordinate of C prime. Oh, this was the question. So I think we are done. We are done with question 4. And then we will continue with question 5. Here's the question, the last one I mean for question 4. We are done with this question 4. And then we will continue with question 5.